Okay, so this is the long-awaited 10.4. We're going to talk about area and circumference. It's pretty straightforward stuff. As long as middle school wasn't that far away in your life, or high school, this isn't going to be too bad. Alright, so the objectives, we only have two. We want to be able to use area formulas to compute the areas of plane regions and solve applied problems. Basically, we're going to use the area formulas to find areas, okay, and use that to problem solve some word problems, right? And then we're going to use formulas for the circle's circumference and for the circle's area, right? So we are going to have a lot of formulas in here. The first formula that we're going to have is the area of a rectangle and a square. Now, typically we say area is equal to length times width, and of course the length is one side and the width is perpendicular to the other side. I actually kind of like to use area is equal to base times height, where this is going to be the base and this is going to be the height. And then this becomes very consistent for the rest of the problems. Now you'll notice the height is at a right angle to the base, and that's going to be very important. Now, it is true that the area of a square is side squared because both sides are the exact same length, but you can actually use the base times the height for this one also, and so the area is also equal to the base times the height. It's just that they're the same number, so it ends up being squared, right? Now, most of us can do simple calculations of the area. I'm going to adjust this real quick, alright? But what if the figure is irregular? What if I've got a rectangle with another rectangle attached to it, okay? And you're thinking, oh man, what am I going to do with this, right? And so this is 3 feet, this is 13 feet, this is 6 feet, and then this is 3 feet, and you're going, man, this is just crazy, okay? Well, basically what I need to do is I need to make two rectangles out of this. So the first step is to always make shapes whose areas you know. Alright, and what I mean by that is the formulas for the areas that you know, something you can calculate. And so what makes sense here is to go ahead and draw a line up this way and break this into the first rectangle over here and the second rectangle over here. Now you can see from here to here is 13 feet. So to calculate each separate shape. So for the first rectangle here, the area of that is going to be 3 times 13. And I'm going to pull out my calculator, and hopefully it doesn't take too long. It's 39. Okay. And for the second rectangle, well, the base is still going to be 3. The area here, the base is 3, but the height is 6 plus this little part right here, and that little part right there is 3. So this whole height right here is going to be 9. So it's going to be 3 times 9 is 27. And then once you've done that, you're going to sum the areas together. And so 39 plus 27 is, I could have done that in my head, but 66 square feet, because all of the measurements were in feet. The one thing that you really don't want to do is don't go like this and get this one, and then don't go like this, right, to get the 6 and the 3, and then you've got this whole area that's blank. The thing that I see most often is students either leave an area blank or they overlap when they make it. So they count an area twice, or they count an area not at all. And so you have to be careful about this. And this makes us happy because it's pretty straightforward if you can make shapes whose areas you know. Alright, so now what are we going to do? Now we're going to look at the new area formula, area of a parallelogram. And so this is base times height. And you'll see, again, the height is at a 90-degree angle to the base. And so the height always needs to be perpendicular to the base. Okay? Always, 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 and forever. And they have this very nice thing where they cut this little piece of the triangle off, they move it to the other side, and they show you that it's a rectangle. And that's pretty cool. A little proof without words. Alright? So now we want to find the area of a parallelogram. And so it's a pretty straightforward process. Here my base is 8. Here my height is 4. And so I'm going to get 4 times 8 is 32, and centimeters times centimeters is centimeters squared. Don't forget your units. Units are very important, okay? And they come just right from, just like if you were multiplying c times c in algebra, you would get c squared. Centimeters times centimeters is going to give you centimeters squared. And so that's the area of that parallelogram. Next, we have the area of a triangle. And the area of the triangle is given by 1/2 the base times the height. And hopefully you can see why. If I took this triangle right here, and I went ahead and duplicated it and put it up here like this, where this is my height and this is my base, you can see that it makes a parallelogram. So one triangle is half of a parallelogram. So that's where the 1/2 the base times the height comes from. It's literally half the area of a parallelogram that it would make. And again, the height has to be at a right angle. So as I look at this particular picture, I'm just going to draw in the... Alright, so you've got 10.5 meters here, 14 meters here, 16 meters here, and 10 meters here. The idea is, this is a side. It's not a height, it's not at a right angle. This is a side, it's not a height, it's not at a right angle. This is the height, it is at a right angle to the base, and so the area here is going to be equal to 1/2 of the base, 16, times the height of 10. And of course 10 times 16 is 160, and half of 160 is 80. And of course this is meters times meters, so you're going to get meters squared. And please don't forget the units. Please don't forget units. Alright? It's really important. Okay. Now this I hadn't seen in a while. Okay, I kind of totally forgot about this. But here's the area of a trapezoid, okay? And what I had totally forgotten was how they got the formula for the area of the trapezoid. So I really, really like this slide. The area of a trapezoid with parallel bases A and B and with height h is given by the formula. If you'll look, this is a triangle right here, okay? And so the area of that triangle is 1/2 the base, which is A, times the height, which is h. But then there's also a smaller triangle, right? This one right here that's made up of the smaller base and side and this diagonal that was put in. And so this has an area of 1/2 this base B times the same height that's 90 degrees to the base, and it's right there. And so when you factor that out, you get 1/2 h times one base plus 1/2 h times the other base. And so this makes us really happy, and I think this is a really nice way to think about the area and to remember the formula. But again, it's still sort of 1/2 the two bases added times the height. So when I go to do the application problem, right, as I go to do the application problem, my area is going to be 1/2. The height is at a right angle, there's the 13, times the two bases added together. So 46 is one. So there's my first triangle, and 32 is the other one. So that's my other triangle. Now, you can certainly do the algebra on this, but we're allowed to use calculators in our class. So I'm actually going to type in 1/2 times 13 times, and then in parentheses, in your calculator, you want to make sure that you put those two numbers in parentheses that are there. You get 507. So check that in your calculator, but you should get 507. And remember, this is still feet times feet here, so that's going to be feet squared. All right, and feet times feet here is also going to be feet squared. So it's 507 feet squared. And remember, units are important. I can't stress that enough. In chemistry, in physics, in engineering, in, even in biology, units are really important for the milliliters and centiliters and volumes and stuff. In all your science and math classes, the units are just going to be really super duper important, okay? So you want to make sure that you're paying attention to those, and that's why I'm making a big deal. All right, so now that takes care of most of our plane solids. They're not solids, I'm sorry. That takes care of most of our plane figures, all right, except for the circle. All right, so we do want to take care of the circle. It's a set of points in a plane equally distanced from a given point in its center, where r is the radius is a line segment from the center to any point, and the diameter is a line segment through the center whose endpoints both lie on the circle. It is twice the radius, and so that's going to help us when we do our formula, right? So, if we want to find the circumference of a circle with a diameter equal to 40 yards. Well, wow, it would be really nice to know what the circumference was. Well, the circumference is equal to pi times the diameter, or 2 pi r, because remember, the diameter is twice the radius. So that's where the 2 comes from. And this is the way the ancient Greeks defined it, is pi is the ratio of the circumference to the diameter. So this is sort of by the Greek definition, and then we have this, all right? So to find the circumference, I can either go pi, which we're going to estimate in the book to be 3.14, times the diameter of 40 yards, or you can do 2 times 3.14 times half of the diameter is going to be 20 yards. Now, of course, these are both going to give you the same answer. 3.14 times 40 is 125.6. And this is a circumference. It's the distance around. Okay, you'll notice that the 3.14 doesn't have a units, and it's just multiplying by the yards. So the unit is just yards. There's no squared or cubed or anything, because it's just a pure distance. So again, units really important. Alright, and now last but certainly not least, we have this one, which is the better buy. You have a large pizza, 16 inches in diameter, for $15. Medium pizza with an 8-inch diameter for $7.50. $750. That's an expensive pizza. Excuse me. So which is the better buy? Well, what we're talking about is the cost per... Well, these are in inches, right? These are in inches. So what we're talking about is the cost per inch or square inch, right? For the area of a pizza. So what I'm looking to do is I'm looking to figure out what $15 divided by the area of the large pizza is, and compare that to the $7.50 over the area of the medium pizza, right? And you're thinking, well, this one has twice the radius as this one, and this is twice the money as this one, so they should be equal. But what I'd like you to remember, okay, as we go through this problem is when you're talking about the diameter is not only getting bigger in this direction, the diameter is also getting bigger in this direction. And so because it's getting bigger in two directions, it may be getting a whole lot bigger than an 8-inch pizza that has a diameter this way, but only has 8 inches of reach in the other direction too. So there could be a huge difference in the area, and as we see, there really is. This one is much, much bigger than the other one, and by more than a factor of 2. Alright, so how are we going to do this? Well, we're going to start off with the area formula. The area of a circle, everybody say it with me, is pi r squared. Okay? So as we're looking, we have the $15 over the area of the large pizza is going to be 3.14 times the r that's squared. Now remember, it told us that it was a 16-inch diameter. So 16 inches in diameter is going to give us a radius of 8. Okay? And so now you're going to have $15 divided by, and I'm going to put 3.14 times 64 into my calculator. Okay, my calculator is doing something weird. And so what am I going to do for the medium pizza? Well, I'm going to do the same thing. I got the $7.50, and that's going to be 3.14 times, well, that one was 8 inches in diameter. So this one is only going to be 4 squared. And so actually you can already see that you're going to have 3.14 times 64 here when you square it, but you've got $7.50 is going to be divided by 3.14 times 16 down here. Well, this is 4 times bigger, right? This is 4 times more area than this one is, but the price is only twice as much. And so now when I take 3.14 and multiply it by 64, I get 296. When I multiply 3.14 times 16, I get 5024. So I get right? And so if you just had 50 and 200, 4 times 50 gives you 200. This one is 4 times bigger than this one. And so now when I divide the 15 divided by 200.96, I end up with about 7 cents. And when I take the 750 and divide it by the 5024, I end up with about 15 cents. And so this one is the better buy because per square inch it's only 7 cents, and this one per square inch is 15 cents. It's almost twice as expensive. Not by pizza, but by size. So the larger is the better buy. Okay, and that concludes this video. Enjoy the pizza.